welcome back to another episode of Hand Tool Rescue. Today we have an antique door mortising machine. So it cuts the hole in the door for the handle or the lock. Very specialized, but very useful considering the amount of work that would have to go into hand chiseling that. Would be a massive pain. So, something like this was invented. I got this, I believe, off eBay like 3 or 4 years ago. Just saw it, thought it was a cool look, and a lot of pieces were broken, which is my specialty. So it arrived very cheaply, and I was impressed kind of by how simple it really was. The only major issues were the fact that it was missing one of these hand wheels here, and that's to kind of tighten it down to the door. And it was also missing the fingers or long parts that would go into the mortise and clear out the chips as you were cutting. So those will need to be fabricated. But other than that, everything else seems to be here, and it's a very simple machine with honestly not too many parts. This did take a really long time to finish. I started this months ago and just kind of waiting for parts to arrive, kind of slowed this all down. And that's just kind of what happens sometimes. Nothing you can do about it. So these clamps here that screw down onto the actual door to hold the mortising machine in place, I thought would come out if I unscrewed it just to its maximum potential, but apparently that's not how it was designed, unfortunately. So I literally have to grind away the peened over end of the threaded rod and snap off the, flat portion. Which seemed to have pieces of fabric or leather in them, so that I guess they wouldn't scratch up the door when you would clamp it down. It's probably, as always, just a giant chunk of asbestos waiting to give me mesothelioma, but I mask up and keep it wet and spray it with penetrating oil, just in case, because I never really know. It was only present on 2 or 3 of the actual threaded portions. The rest, I guess, the fabric fell off at some point. The lengths of the threaded rods are different, and I believe that's to kind of compensate for the fact that one is left-handed and one is right-handed, so when you tighten one, the other one would loosen, so they added a lock nut on one side so that you can lock it down even after tightening it down. And I guess they give a little extra room in the threaded portion to provide room for that lock nut. This is the cutter head. So this entire portion, the portion that says M5 on it, came in a set with a few other cutters. And the cutter itself stayed attached. And you would just kind of quickly swap out the entire head. And then you could take the cutter and sharpen it separately if you needed to. I'd love to find the other cutters, but I highly doubt I'll ever come across any of those. The ones I found online, I think there was one photo that had the separate colors. They're obviously different widths and not necessarily longer. They're just for different widths of mortise, I believe. This portion is nicely machined and cast. It's not too bad at all. And it seems to be still lubricated, which makes me happy, so we don't have to do too much on the restoration of that part, because I was kind of worried that it would be toast. I'm going to throw the whole thing, even with the wood handle still attached, just to kind of see what's going on with the level of finish that it still exists and what type of finish it is. So it does look like some sort of black finish, which would then mean it's probably Japanning. But unfortunately, I don't have enough asphaltum to make a new batch of Japanning, and the one that I ordered is taking really, really long to get here. So we're going to have to go with spray paint with the closest possible match technique that I use to Japanning, and then it'll just have to do for this tool. It's mostly not even noticeable. I'm going to strip the rest of the Japanning off because it will clog up the sandblaster aggressively, but you can only really get so much off. Different paint strippers react to different recipes of Japanning. Sometimes it works, and the next day it just won't work. That's kind of the way it is, and the sandblast is the ultimate cleanser. You can always tell it's Japanning because it melts instead of wrinkles or peels. It just melts into a goo. It's really odd. And still very difficult to get off. You can see how much is still left on that the paint stripper couldn't eat through for some reason. But that's fine. Sandblaster does the blasting. I always go with a acid etching primer first, even if it's not aluminum, which would be the normal use case for an etching primer, just to get the maximum amount of adhesion I can onto these metal parts. I also leave them in a sand-blasted finish to give that extra texture, so there's even further chance of maximum adhesion to the part. It's just me trying to prevent chipping. Because Japanning is virtually indestructible, although it can chip over time. It's very tough, so I got to get close. I got to get as close as possible. And I use the Krylon farm equipment paint. The black low gloss is the exact one that I use if you want to kind of recreate that. These, I've decided, are going to be recast entirely in bronze to up the sensuality factor to its maximum level and replace the one missing wheel. Because there's no way I would be able to machine this with all of its fancy curves. It's much easier to get it completely recast. Now, this is Clark at Windy Hill Foundry in Mississippi. I sent the parts off there. He's a friend of mine, and we have been working together on this project, and he offered to recast them entirely in bronze, which initially wasn't my plan, but I'm glad he suggested that. He had a lot of extra bronze, so why not? He spent the time to get the finish of these really nice. He even added a little extra filler like Bondo to the wheels to get the casting to come out super, super nicely. And he does an amazing job. And he's perfect for these kind of small casting jobs. And if you do need something cast, you can just message him anytime. He will gladly help you out. So this is obviously footage from his foundry. And this amazing old lathe and cool chuck. He's just drilling out the center here to see if there are any voids in the casting to make sure that we have a completely solid piece of bronze here. And they are perfectly casted. So he was very happy with that. I'm extremely happy with these. And I hope to kind of cast more random things in bronze if I can, just because it's so shiny. Here they are back in my shop. It only took 9 weeks to arrive from Mississippi to cross the border, which is ridiculous. But I now need to cut a square hole. And not just a square hole, a tapered square hole. So really the only way I'm accomplishing this is by hand. And I try to get as close as I can to the situation that I have at hand, and I think I did a fairly decent job. I'm not going to hammer them in until All 4 of them are done. But I got fairly close with files, I think. I didn't mess up massively. And it holds in place just fine. You can see the punch marks where they used to expand it out. I'm not going to re-punch them because in case I do want to take these off for some reason, it's just much easier. The punching really locks them in place. And they're in there solid. Once hammered in, like they're not going anywhere. The taper really helps. Anyways. Now, that portion of the threaded rod that I removed with the carbide burr needs another solution, and I wanted something that wasn't permanent. I could have just filled it with a little dab of bronze brazing and then hammered and peened that over. That would have been totally fine, but I just wanted something that I could very quickly remove if needed, if there was ever any further maintenance on this. Not that I'm mortising doors all day, but just for someone in the future, I guess. And it's completely hidden, so I can get away with something like this. If this was not hidden in any way, then I would not do this, especially with this whatever square drive. I don't even know what square drive is at this point. I only do slotted screws. So that's why I went with the tapped threaded hole portion for that. Now I'm oiling everything up like I usually do. All fasteners always get a nice misting of oil, and this will get a little thicker oil. This is 30 weight oil, and that'll really stick on to that casting there as this moves back and forth. It's obviously not moving at a crazy high speed, but it's still moving, and it just needs to move freely and not rust. So that's why we apply that. The cleaned up, very sensual cutter holder is looking really cool. It was an odd type of metal. It's very, very light. It might be something like zinc. I doubt it's aluminum, although it could be. It seems a little too dark. It's something zinky. So that goes on there. Now, this crazy angled Bridgeport mill setup that I have here is to cut the legs or fingers, as I talked about previously, that clear the chips out of the mortise as you're cutting. And the original patent documents have something exactly like this in the drawing, which is kind of a stepped or a toothed square bar that you would shove in the hole, and as it moves back and forth, you will see later on in a rocking motion, it clears out the chips. So I tried to get as close as I can to the patent document or what I can find online, because sometimes those things are not the same. Production models are not the same as the patented models. Now this is the top end of that tooth bar, and I'm just drilling a hole where a spring will go, and that hangs on the machine and allows it to kind of always have a constant pressure against the hole. And you'll see what I mean by the end of the video. You see how it always springs back? That's what you need. You don't want it flopping around. You want it to kind of stay at the maximum edge of the hole at all times. Now we slap this piece back on. This kind of stops you from the entire cutter assembly from sliding right out of the body. So very important. But before we finalize, we need to remake the guides for those tooth bars. They don't exist anymore. They need to be completely remade. I have found some examples online of what was done previously in production, so I'm going to try to replicate that as best as I can, and then, of course, increase sensuality as much as possible, which is always the goal for me. That rod is the portion that goes through the main body casting and is adjustable back and forth with the thumb screws. And this portion is the chunk of steel that holds a piece of wood, which would be the wear block that the tooth bars, the back of the teeth, would rest up against and shift up and down. So that's why I'm cutting a slot in a thicker piece of steel, because I'm going to stick some wood in here and give that tooth rod a bearing surface. I'm also just going to braze these together. I could have welded them, yes, but brazing is so much easier, and my welder is not set up yet. So brazing it is. It's also easier, I guess, to remove the brazing if I did miss up. Need to reposition or something. It's much easier than cutting it and regrinding like crazy with a grinder. This will all be covered by paint anyways, so I'm not massively concerned. I'll just clean it up and it'll be totally fine and hidden. We're going to cut these to size. There's 2 that I need. And I'll clean and trim them up off camera to like a nice square. And fantastic corner. This is the Jatoba that I keep on using for basically every restoration. I bought a chunk of it and I gotta use it. Now I could have used the door mortising machine to cut this, but alas, it's not ready. But this slot here, I'm just gonna finish off by hand. It's the exact width of the tooth bar, so it's gonna fit in very nicely. Here we are, nice and painted. I just taped off at some point along the shaft. I didn't really know where exactly to call it. I cleaned the paint off of the steel portion and then just super glued it into place. It should be completely fine. I'm not massively concerned. And then I'll finish it off with a few coats of shellac just to brighten it up. Do not oil your oily hardwoods. It just makes them really dark and you can't really see all the grain and the figure. So shellac's a good solution for that. And here you can see where they apply that pressure to straighten them out or position them in a certain way that you need for whatever size mortise you happen to be cutting. I don't know. Now I'm going to be fully remaking the handle that I chiseled off into pieces before. The ferrule was damaged and the wood was damaged itself, so a full remake is required in this case. Now I'm using the metal lathe again to do woodworking, using carbide cutters and a super high speed, and it seems to be fine. It's not the nicest finish in the world, but that's what sandpaper's for, so I'm not really concerned. But I'm definitely abusing the metal lathe. Now, cutting the hole, it needs to go about 2/3 of the way in to the entire handle, just so we have enough depth to slap it onto the casting. And here I'm just going to cut the edge off for the brass ferrule, which I need to make after this portion. I stepped up the grits all the way to, I believe, 3,000. It just got aggressive, essentially burnishing at that point. Applied some hardening wax, and then I get it nice and hot by buffing it, and then it melts into the wood pores, and then you're done. It's a really nice finish. It's not too glossy, which I like, and you can still feel the actual wood. You feel that it's wood and not that it's wood coated in a layer of plastic like you would with polyurethane. So yay for wax. Now we part that off, and I'll hand sand that later. Here I am just maxing out the depth of cut on my lathe. It's not happy about it. My lathe is also not bolted down to anything, which is really, really not a good idea. But it gets the job done. I'm personally okay with it. Now that we've got the proper length, we're going to bore out the inside to match the bore that we need to hammer this onto the casting so that the handle stays in place very nicely. Now I'm just going to super glue this on as well. I could epoxy it, but super glue seems fine. Epoxy is better for more impact resistance, but I don't see this getting massively smashed up over time. And in some cases, these weren't even glued on and just pressed on, which I could have done. But I just wanted some glue in case there's some seasonal wood movement. I'm just sanding that nub off that I had to be there due to the parting off, and then buff it just a little bit again, and we are ready to slap it on. You know how I just said I'm never going to impact it or hit it with a hammer? Now, to sharpen the tiny, tiny cutter, which is a little bit damaged, I'm going to have to take off a bunch of material. But I'm going with my auger bit sharpening file, which is literally perfectly designed for this. And then I'm using my diamond stone plates to go up the grits to sharpen 3 sides as much as I can to get crazy, crazy, crazy sharp. So we have a super useful tool to actually cut some wood. The cutter definitely needed like just a major, major sharpening. It's just brutal. Now I'm going to remake those cloth pads that I removed off of the little weird circular, I don't even know what to call them, padded portions. Just because leather is obviously fantastic. And I'm just going to super glue these on as well. It'll hold just fine. I removed the paint so we get a better adhesion, not just to the paint, but to the actual steel. And then we are ready to actually test it out. So you can see where I pre-drilled holes. That's part of the instructions that I honestly actually really found online. There are instructions for this. And you could see how the teeth move in and out or back and forth out of the holes as you work through this over time. So you'll see me just eat through. Yum, yum, yum. So yummy. And you can see how the chip clearance kind of works. Over time, it lifts it up and out. If there were a lot and I was going really deeper, then yeah, we can do that. And that's basically it. So I cut about, half an inch or a little more, 3/4 of an inch deep in like 10 seconds. It was fairly clean. The walls were really nice. I was impressed. The tool definitely does work, and it makes quick work of what you're doing. But this seems like the setup is potentially an annoying slowdown. I'm not sure, but it does look very cool as a tool. So I may keep it around, but in all honesty, I think we could probably sell this. I don't know. Maybe somebody wants it. I don't plan on mortising an aggressive amount of doors anytime soon, but if you are, let me know, and we can work something out. Anyways, thank you all for joining me once again, and I'll see you in the next one. Later.